So what we did yesterday was Gaussian elimination. This is what's called Gauss-Jordan elimination. Now, the only difference between Gaussian elimination and Gauss-Jordan elimination is you do more work inside the matrix in Gauss-Jordan elimination, but you don't have to do any works whatsoever outside the matrix. So, what you want is you want a matrix that looks like this.
Good morning.
All right. So this is what's called reduced. I actually don't think there's a hyphen there. Reduced row echelon form. All right. Now the cool thing about this is, if you think about what this first equation represents, this first equation right here represents x plus 0y plus 0z, so just x, equals a. So you can immediately tell what x is based on the matrix. Similarly, where's my little x? There it is. Similarly, you can do the same thing for y and the same thing for z. So once you've got this form, you've got your solution. There aren't any equations to mess with. Okay. I forgot to change that to yellow. Oh well. All right. So let's try this out. And I promise these are only 3 by 4. They're not 4 by 5. Everybody's like, thank God. You never thought you'd be like, yeah, 3 by 4. All right. 3x minus 2y plus 5z equals 31. X plus 3y minus 3z is equal to negative 12. Negative 2x minus 5y plus 3z equals 11. Okay. Now, when we make our matrix here, remember that you need a 1 in the upper left. I hope you can see that you can swap rows. Do you want to just go ahead and swap rows as we write the first matrix so we don't have to write it out and then write it again with the rows swapped? That sounds like a good plan to me. So let's go ahead and just swap row 1 and row 2. So this would look like 1, 3, negative 3, negative 12, and then 3, negative 2, 5, 31, and then negative 2, negative 5, 3, and 11. Now what? Yeah, I gotta get a 0 where the 3 is and a 0 where the negative 2 is. So how do we get a 0 where the 3 is? So negative 3 row 1 plus row 2 into row 2. So let's do that. So this is 1, 3, negative 3, negative 12. This would be 0. Next one would be negative 11. 14. And then 67. Does that be 36 plus 31? All right. Somebody else, what would I have to do to get the negative 2 to be 0? Right. So 2 times row 1 plus row 3 into row 3. That's going to be a 0 because that's the whole point. 2 times 3 is 6 plus negative 5 is 1. Ooh, that's cool. That's always nice. Negative 6 plus 3 is negative 3. And then negative 24 plus 11 would be negative 13. Now what do you want to do with it? Yeah. So switch the second and third row. I like it. And the cool thing about Gauss-Jordan elimination is the first row doesn't stay the same the whole time, so you don't get sick of writing it over and over and over again. All right. Now what? Yeah, so this 3 needs to become a 0. But you're going to use the same principles to get that to be a 0. You're going to multiply this row, which is row 2 where the 1 is, by the opposite of the 3. So that'd be negative 3 row 2 plus row 1 into row 1. So row 2 is going to stay the same. And now I need to calculate a new row 1. Well, because of this 0, the 1 is going to stay the same there. This is going to be a 0, and I really only have 2 numbers to figure out. So negative 3 times negative 3 is 9, plus negative 3 is 6. And then 39 minus 12 is 27. Okay. So now what? All right, so how would I get that? Yeah, 11 times row 2 plus row 3 into row 3. Because that'll get the negative 11 to be a 0. This is going to stay a 0. That's going to become a 0. Now 11 times negative 3 is negative 33. That plus 14 is negative 19. 11 times 13 would be, or negative 13 would be negative 143. Plus 67 would be negative 76. Then what? Not yet. I got to change negative 19 into 1, and then it's going to be way easier if I get that to be a 1, because otherwise I got to figure out what negative 19 I have to multiply by to kill the 6. Which, in theory, isn't all that hard, but still, it's a lot easier if you just get a 1 to start off with. All right, now, so to change negative 19 into 1, whenever you're trying to change something into a 1, you need to multiply by its reciprocal. So negative 1 over 19 are 3, which is essentially dividing everything by negative 19. So the first row stays the same, the second row stays the same, and then the third row becomes 0, 0, 1, 4. And then, all you got to do is use this one to kill off the stuff above it. We've got it. You tell me. So 3 row 3 plus row 2 into row 2, because you're going to use this 1 that's in row 3 to get rid of this negative 3. So row 3 is going to stay the same, and then I have to calculate row 1 and row 2. Well, the beautiful thing about this is the first two numbers are going to stay the same because of these zeros here. I know the third number is going to be a 0 because that's what I designed it to be. So at this point, I only have one number to figure out. And literally, it's going to be 3 times 4 is 12 plus negative 13 is negative 1. So the further you get into this matrix, the easier the calculations become. Somebody else tell me the last step.
Negative 6 times 3 plus 1.
Oh my God. You actually answered a question without being called on. Taylor will be so proud if she watches this video. They usually get pretty hosed if they don't watch them, so anyway. Those three numbers, those two stay the same, the 6 becomes a 0, so I only have one number to figure out. So negative 6 times 4 is negative 24 plus 27 is 3. And the problem is done because the x is 3, the y is negative 1, and the z is 4. Yep. Really, the extra part wasn't all that bad. You had to do, whoops, you had to do this calculation right here, and these two calculations right there. But honestly, those, you only had to figure out one number each. So really, that wasn't that bad. So really, it's personal preference whether you want to use Gaussian elimination or Gauss-Jordan elimination. Okay? But there you have it. Now, we're going to render this video, and then we're going to do the last example.